Okay, good evening. I'm deeply sorry this talk won't be fun. It will be subject heavy. I originally wanted to talk about 3 things that you really can't do in template metaprogramming, but then I found out that you can do all of them with varying degrees of convenience. So instead I want to talk about one really obnoxious thing, at least for me, in template metaprogramming. How many of you are familiar with std_apply? Do I have to explain it?
Unfortunately.
Okay, not many of you. std_apply is a really nice utility which allows you to take a callable that accepts a regular list of parameters and take a tuple which contains matching types in correct order, and it will unpack the tuple and forward it into the callable. And suppose I want to do something slightly similar. I have a tuple of strong types, no types are repeating within that tuple, and I have some kind of predicate, a callable, which only accepts a subset of these types that are contained within the tuple itself. And I would like some template metaprogramming magic that would figure out what are the parameters I can call the callable with, extract them from the tuple, and forward them in with fold expression as you can see on the slide. And first of all, callables are opaque types, or many different things can be callable. So deducing from callable the actual template pack of parameters is hard. You need to write a type trait. And the second bit of this problem is how you actually get that deduced template pack into this function declaration, like into the templated parameter list. And this is a 2-part problem. First of all, when you are writing a type trait, you are doing some metaprogramming magic. You eventually arrive at the type, and you alias it with the using directive, so you can get it outside of the type trait. However, in this case, we are operating on template parameter pack, and there is no way how to simply alias a list of types. There's nothing such as using ... to capture them. Instead, you need to use a template wrapper, and many people default to std tuple, and put the template parameter pack inside of that and alias that. And the second part of the problem, if you have this tuple, how do you tell your compiler, hey, in this parameter list of templates, I have something that is just a wrapper and I'm interested in whatever is inside. Like, it's easy to deduce what are the types contained within a tuple when you have an actual instance in your parameter list. That's easy, that's the first example. But second example, well, I'm not familiar with any kind of syntax that will allow me to tell the compiler to do so. So what is the solution here? First of all, as Raymond Chen proposed on his blog, The All New Thing, don't use std tuple as your go-to type wrapper, because the types contained within might not be the default constructible. So you can't simply construct it and pass it to the bar function. Instead, write your own templated wrapper, and you can use whatever alias inside that you need. You can alias how many types are in here. You can make an alias for nth element, first element, head, tail, whatever you need. The point is, it stores no actual data, so you can instantiate it just fine. And the second part of the solution is that you need to create an outer API that is nice looking and convenient for the user to use, and deduce whatever you need to deduce, instantiate that, and pass it into some inner function that can do the actual work of your template. And that's it. I don't like this solution, even if the indirection and the negligible overhead of the instantiated wrapper were optimized away by the compiler. I hate writing that boilerplate code. Also, you could save, I don't know if you can save anything, but there's also an alternate approach with std integer sequence, but it would boil down pretty much the same thing. And yeah, I would like to have some kind of syntax that would allow me to do this with just one function definition. Thank you for your attention. If by chance you know a better way, perhaps Hanka knows, then I would very much like to hear it. have any questions, please shoot. I hope we have a couple of minutes for them. If you found this talk interesting, you can follow this Linktree link to get to my blog and my Tuesday coding tips, which are partly C++, partly clean code. You might find that interesting. And if you want to bookmark this presentation, the last link will tell you to bring you to the download link. Thanks for your attention.